Hello, welcome everyone. Thank you for joining this lightning talk today. We are going to talk about reinventing state services with Databricks and specifically focus on a particular state and two success stories, one in health and the other one in transportation. I'm joined here today by Michael Powell, who is Section Chief at California Department of Public Health, Rex Phillips, who is a principal at our Health and Public Service Strategy Practice, and then I'm a managing director within our strategy practice for Health and Public Service. So let's get started with this. The state that we are going to discuss today has embarked upon a fearless path of data and generative AI exploration. And this has been spearheaded by the governor, who released an executive order in September of 2023. So in partnership with the state, private sector, and academia, this state is pursuing bold and complex ideas that's transforming solutions into long-lasting benefits for its residents. Today, we are going to explore two such stories, one for the Department of Health at the state, and the other one on the Department of Transportation. So we'll start with the Department of Transportation story. The governor of the state recently did a press briefing, and to quote him exactly, generative AI has come to traffic management in the state in a way that does not exist in any other state in America. This underscores the significance of the work we are doing with the Department of Transportation and essentially how this solution is being leveraged to not just make our roads safer, but also developing solutions that help with the traffic congestion within the state. The other interesting point that the governor made was that he perceives generative AI as an efficiency play, not in form of reducing people, but enabling the departments within the state with AI-enabled tools that allow them to serve their residents better, more effectively and more efficiently. So let's talk a little bit about the background of this department. So this is the Department of Transportation, and they are responsible for 52,000 lane miles of state highway. They are responsible for the traffic and safety on this highway. Now, they're trying to solve for two key problems. The first one is the high congestion and the cost associated with this high congestion in the state highway systems. And this cost comes with delay in passengers and commercial vehicles, as well as the cost which is associated with increasing emissions. So the cost is definitely twofold there. This cost is compounded by more than 300,000 people who are super commuters, which means they travel 90 minutes in one direction every single day. The second problem that this department was trying to resolve is to reduce road deaths. So on any given day in the state's transportation system, 10 people die. There are 10 to 12 road deaths on any given day. So obviously this is one of their critical problems and part of their Vision 2050, where they're aiming for 0 road deaths in the state highway system. What they need, the need of the hour, hence, was building a traffic mobility insights platform that provides them real-time traffic data that is multimodal, that is scalable, and that is AI-enabled. And they want to leverage this traffic mobility insights platform, one, to analyze traffic patterns, address bottlenecks, and reduce one of the problems that we talked about, congestion, but also leverage this solution to optimize and make long-lasting strategic infrastructure investments that the residents can benefit from in decades to come. So let's quickly talk about the high-level solution for the Traffic Mobility Insights platform. So on the left, you see the variety of data sources that this solution takes in. So that includes the state transportation system on traffic performance, safety, and other things like transit data. But it also includes a lot of unstructured data coming from video feeds and traffic camera feeds. Additionally, we are also ingesting third-party data all around transit data and traffic insights. So there's a whole set of data that comes in, and then there is weather data, equity data, which is just, again, that those are like all different sources. So again, there's data is everything in this solution. And the first two layers of our solution, the infrastructure and the data layer, that's where we are bringing in all these data sets together and establishing a unified governance. The layers on top of that, the advanced analytics, they cater to traffic-specific AI models that enable you to analyze patterns as well as share potentially counter recommendations. And finally, on top, you have a generative AI interface. So there were many use cases that we built on this. Most of them catered towards, again, traffic congestion, but some of the details around types of HOV lane improvements that this department could do, detection of traffic incidents, and very critical to this department, emergency evacuation management. What are the ways to manage evacuation options in case of a disaster? So high impact solution. Let's talk very briefly about the data. So we spoke about unified data governance in many of the sessions today. This department was the opposite of it. So every data set that you see here was a silo, huge volume of siloed data sets. PEMS, as an example, is their traffic performance data, but that did not talk or in any way have any unified solution with the SWITTERS data, which is their crash data, or with any kind of transportation system network data. Add to all of this, there was a need to layer in spatial analysis. So there was a need to add in geospatial data into the mix, so the insights were meaningful, as well as there is an absolute need for real-time data, because this is traffic management, this is real-time incident management. So this makes it a very complex data ecosystem that we had to solve for, and 90% of the solution is essentially how we manage that data, and we applied unified governance on that data. So the size that you see is the size that we, in form of data sets, 1.5 terabytes. It was just for a proof of concept. So certainly there was just that the actual data volume is at least like 10 to 15x that. So let's go into our solution very quickly. We are, again, no prize for guessing, bringing all the data together through a Databricks Delta Lake. We are leveraging Unity Data Catalog for bringing all unified data governance across all the data sets that we mentioned, as well as driving lineage through them. Autoloader is being used to bring in data from the multiple sources, and there's tremendous scale that can be accomplished from it. There's a medallion architecture established for bringing in the raw data and then processing it and having more meaningful data sets in the semantic layer. And then finally, a set of very powerful foundation models leverage this data for a variety of use cases, including identifying traffic bottlenecks or proactive countermeasures to traffic bottlenecks, as well as proactive reduction of crashes. The whole roadmap of the solution is to go from reactive to proactive response strategies, and from manual assessment, which can take days, to automated assessment through the solution that we built. So to that end, the future roadmap includes instant insights that can be enabled through Genie and AI BI tools, all the while where a traffic engineer can converse with this solution in a natural language. This is the Department of Transportation, so they have close collaborations with universities, including UC Berkeley. So data sharing options through Delta Live and data marketplaces on the roadmap. And last but certainly not the least, for the solution to be effective, the traffic operator needs real-time streaming data from the traffic cameras. So we have structured streaming in our roadmap to enable them to do that. This solution is turning what was taking 2 to 3 months of work by the traffic engineers into 2 to 3 days, and reducing high cost into dollars saved, and most importantly, crashes into lives saved. So this was the story on our Department of Transportation. I'll now welcome Michael to come in and talk about our Department of Health solution.
This may be the most bizarre way I've presented in a long time. Do I got good volume? Okay, awesome. So I just want to talk a little bit about immunization data and how with the Department of Public Health we used our data tools during the pandemic specifically. And prior to the pandemic, immunization data, although we had immunization data, it wasn't required to be sent to us. If immunizations were given in the state of California, they usually resided with an EHR or a medical provider's office, but not necessarily sent to CDPH. During the pandemic, this all changed. Obviously, with COVID vaccinations being required to be sent to the registry, we had to have a way to show this data. We had a reporting requirement daily to the CDC for all COVID data. In addition to that, we had other tools that we needed to implement to get that data out to our local health jurisdictions and others. And as you can see illustrated on the slide, where it says immunization data now, when the pandemic started, that was our immunization data. That's all we had. Since then, we've implemented the digital vaccine record. If you're a resident of the state of California, hopefully you've used this tool to get your own immunization record. If you haven't, hopefully your state has that as well. With that digital vaccine record, we also have other tools for the virtual assistant for people who couldn't find their vaccination record or needed assistance in getting that record. Among all of this, there were a lot of other things that we wanted to do with the data, that we needed to do with the data, and we didn't have the tools to do that. And that's where we partnered with Accenture to help build those tools. And with that, I'm going to turn it over to Rex to go into more of the technical solution. He's going to be much more interesting than me anyway.
All right, so the key point of what we're going to go for here is to build a solution that would leverage Databricks to do some very important processing, which is powered by Databricks' ML capability using MLflow. And it's to expose this now as a software as a service. We called it analytics as a service. Key to doing this was to first process everything that we had in Databricks and then to expose it using our cloud-based solution with an API. So in this case, we had Databricks do the processing, exposing it to a NoSQL graph database, which would then be shared with, in this case we use Azure API Gateway. Also, while we did this, we wanted to make sure we could expose this to any potential, expose this to any potential clients or other markets that we have. So there we leverage the Delta sharing with the hope of then applying the marketplace going forward. Okay, so the actual layout of this. So what you see here is a multiple of different inputs that we had coming in from the left. We did use Azure Data Factory to consume things. Now the reason we use Azure Data Factory in this case instead of some of the native capabilities is we had to do orchestration across multiple different systems. So Azure Data Factory is handling our orchestration. It's also ingesting the data. It's loading it into our ADLS, where we're then ingesting it using autoloader, putting it through medallion architecture, and this is also where our ML processing happens. You know, what's unique about this solution is we're doing patient matching, or the master person index. Master person index is essentially a 50 million person categorization task. We have 50 million people in our system. We're trying to match those together in order to make sure that they're all uniquely identified. So we go through the process, we load our data in, we run it through medallion architecture, we then do our ML-powered matching. After we get that, that's when we're then going to load it back, in this case to ADLS, where it can then be consumed for all of our different groups. So this is the data that goes to the CDC, it goes to our API gateways, which are then consumed by some of the other different groups that we have available. By doing it this way, we're able to leverage the power of Databricks to power one of the most powerful master person indexes available in any state, which is truly a marvel. So, I'm going to turn this over to Michael again to kind of wrap this up. Using the power of Databricks, we have been able to do a massive system to handle all the different members of this state, to handle all the different immunizations for this state, to handle 50 million people. And it's truly been a work and a wonder.
Thanks, Rex. So I'm going to close it out just by giving some numbers of what we were able to accomplish with this solution. As Rex mentioned, we have over 50 million patients in the immunization registry. I know that's greater than the population of California, but it is a life-to-death registry, and people who move in and out of the state, they'll remain in our registry forever. We have over 20 million vaccination records that were downloaded by individuals throughout the state. We have 8 language translations for the digital vaccine record. And the digital vaccine record solution that we implemented, 6 other states have adopted that same solution, although either in part or maybe slightly modified, but they are using the solution that we developed the code for. And another big accomplishment was 1 hour from vaccine IS submission to reporting. With the number of records, we have 680 million doses in our registry. That's a really big task to be able to report that quickly. So all in all, I can say that this was a successful endeavor. We've had a lot of success. We hope to continue the success, and we won't talk about funding in this meeting, but we hope to continue that success and everything that we've learned over the last 5 years. And with that, I'll close. Thank you very much for your time and attention today.